Thank you so much for being here today. I hope the summit has been going well. Track 8 of day 2 looks at integration and redesign. And the talks we'll be covering in this session are track 8.1, which is the process of strengthening fleet management in the Tanzanian Medical Store Department. Track 8.2, which is strengthening the health supply chain with drone logistics. And then track 8.3, which is data analytics and application for logistics and supply chain management in Zambia's public health supply chain. So I'm going to kick us off by sharing the presentation for track 8.1, after which we'll have a few minutes for Q&A.
Welcome, everyone. It's my great pleasure to be here today, together with my colleague Riaz presenting at this event. First, we'd like to thank the sponsors, Chimenge, the William Davis Institute, and USC Marshall. Thank you for enabling this great event. My name is Paul. I work with WFP's Global Fleet Unit in Logistics, and we appreciate the opportunity here to be here today to present what we believe is a great example of sustainable capacity strengthening. And with this, over to you, Riaz.
This project was implemented through a new approach in which WFP supply chain officers based in Tanzania worked closely with a team of headquarters-based WFP fleet management experts to identify gaps and bottlenecks, and particularly how medicines could be delivered in a more efficient, timely, and cost-effective manner. This is an inclusive approach, as the government was involved in every stage of planning and implementation to build a more sustainable national capacity. Key things implemented in this project is the fleet management tool. It's a powerful Excel-based software in which information can be captured from different sources and then processed and analyzed using different key performance indicators. This will help the MSD management make well-informed decisions about their operations.
Unaonyesha namna gani magari yanavyofanya kazi kwa ufanisi, na unaonyesha namna gani madereva wetu wanavyofanya kazi. Pia unaonyesha namna gani magari yetu hata pale yanapokuwa yamepelekwa matengenezo, tutaona kwamba unatumia siku ngapi, maana ndio mfumo unavyoonyesha hivi. Na unatunza kumbukumbu kwa ajili ya usambazaji. Tutaona kwamba gari linapoondoka kutoka kwenye zone, tutaona kwamba limebeba boksi ngapi.
Another highlight of this project, or from the training that we had from the two different groups, is the inputs from the drivers. We have seen that they have a lot of challenges that they go through while in distribution, and most of them, they fail to express those challenges. So I believe with this tool, we'll be able to get more challenges. I mean, challenges as in what they go through while delivering the goods. So we can be able to help them and to make sure that the goods are delivered at the right time and the right quality. So what we are actually expecting from our drivers to be on the forefront, because they are the ones who are actually going to the health facilities. They're basically holding MSD. So we are also planning on having more training sessions with the drivers, because they are the key persons in this fleet management tool or the fleet management system. So it is our our target or our goal to make sure that our drivers are well trained and they are motivated in the deliveries that they do, because without them we will not be able to fulfill our customer satisfaction.
System hii ya trip sheet ni nzuri. Kwanza inasaidia sana kwa sisi madereva kujua idadi ya mzigo niliochukua na nimeshusha sehemu gani na sehemu gani, kunipa kumbukumbu nzuri za wakati ule ninaposhusha au mpaka nitakaporudi, baada ya kuwa nimesahau kwamba nilibeba mzigo wa ukubwa gani, lakini trip sheet inanikumbusha kwamba mzigo wako ulishusha huu na kiasi fulani kila sehemu, kila kituo ulichoenda.
The tool has supported or assisted us to make good planning for our trucks. The tool has also supported us very much on timely delivery of the consignment to the customers.
One of the priorities of the project is to make sure that the new fleet management system and procedures are sustainable. This is why the MSD staff was trained by the University of Dar es Salaam, for instance. This way, the knowledge will remain in the country and they can pass it on to the new employees.
This training is important for Tanzanians because it provides efficient and effective ways of managing fleet and transportation in the country, especially in the area of medical supplies.
To me, this project serves as a model for capacity development, as it was designed and implemented with full participation of the donor, which is the Bill and Melinda Gates Foundation, the government institutions, and the World Food Program. MSD staff and management took this project positively and seriously. They have shown commitment in rolling it out and benefit from the learning. Let's remember, an efficient supply chain can save lives and change lives. And who knows it better than WFP?
Thank you, Riaz, for this impressive introduction. It's great to see all the various stakeholders who contributed to the success of this project. So let's have a look at the different phases, starting with the problem statement, then the approach, touch on the pilot, and finally present the results. Of course, at the beginning, it was important to understand the needs of the partner, and while the initial scope was actually to support the technical specifications for a new fleet management system, we found there was a gap in the maturity level of how the fleet data is being used. So we took a deeper look and analyzed the structure and found that while there was a functional fleet management, there was no institutionalized fleet management unit within the organization, but parts and bits in logistics and transport. So we compared the MSD processes with those that we have in WFP fleet and realized that we have both a very similar mandate, both non-profit similarities in the way we operate, a central unit that is overseeing different zones and different regions of WFP. So given these parameters, we needed an appropriate approach to solve this issue. So what we decided to do is to take a parallel approach. On the one hand, shape the foundations of a successful fleet management system to secure an in-depth understanding of the logic behind the fleet management data, and on the other hand, to introduce a system simultaneously because there was an urgent need to have a tool to manage the fleet of roughly 200 vehicles. As a regular system or software implementation project may take up to 1 year, we needed something faster. We chose to build our own fleet management system. The basic one, fulfilling the essential functions required in fleet management, so providing performance measuring, cost control, KPIs and utilization, fuel consumption, and driver behavior. And as Riaz mentioned earlier, we decided to implement it as an Excel-based fleet management system, which may or should come as a surprise because fleet management is usually not one of the prime use cases when you think about Excel, but it did make sense for several reasons. So first and foremost, the speed. For example, the speed of development, as this tool was developed by the fleet unit, especially for this project, we had a very small group of stakeholders in this phase, so we could skip the loop with IT or even external providers, so that saved us a lot of time. Also very time-saving was the fact that we did not need to establish a new software within MSD. because Excel was already available on all the computers of the staff involved in this project. So also that one saved a lot of time. And especially in this one, speed was crucial because we needed data quickly to feed and sustain the information channels from the zones to HQ and MSD that we intended to establish. So that was the first reason. Second, flexibility. We had a minimal adaptation time to new or changed requirements during the project implementation, as we could do overnight runs and basically come back with a customized or revised updated version to the partner next day in the morning. The third reason would be transparency. As all the calculations were open code, it was very clear how we got from the data we captured on the trip sheets, for example, to the graphs, as you can see here. So this allowed to develop a profound understanding of the logic of fleet data processing for MSD staff who was working then on the systems. And a fourth reason why this did make sense to use Excel was that this was built for temporary use as an interim system, basically on the path towards a web-based fleet management solution in the future. So what you can see here on the left side is the dashboard on the zone level, in this case, the Dar es Salaam zone. We have the 8 KPIs represented by the 8 graphs, and on this level, each bar is one truck. And as said, it was required to have this data fairly quickly as possible because we needed to feed the information channels from the zones to HQ. So as you can see on the left, we had 3 zones in our pilot. We had the Dar es Salaam zone, the Doma zone, and the Dar Logistics. And all these had their own system feeding into the MSD HQ dashboard, which you can see on this slide, which is the aggregated data, where each bar represents one zone, showing either cumulative or average values depending on the KPI. And this architecture corresponds to the fleet structure that we want to establish. And we will have a look at the KPIs in a very bit, but let's first have a look how we got to the point to have actual operational fleet data within only a couple of weeks. So in order to be able to capture fleet data, the current process were analyzed. For example, as you could see in the video, we took a look at the trip sheet as the logbook entries, and based on the existing documentation, we checked what is in place, which info is missing that we need to capture in order to only add a minimal additional manual workload, because we thought that this would facilitate the acceptance of the new procedures. And then together with the MSD lead users in the project, we defined and documented everything to ensure that this process knowledge may be passed on to further colleagues in MSD to enable a scale up. And a third point here as well was that we had trainings both on the fleet management system use and in general on fleet management with various stakeholders, including the director of logistics, drivers, data clerks, warehouse managers, which really built a common understanding of fleet management within the organization. And now let's have a look at the results. One of the KPIs that we monitored during the pilot was the fleet of vehicles utilization. And while you could say that the most striking element on this slide is the actual increase in utilization of respectively 7% or 12% from the start of the pilot in January 2020 to the overall period from January to May. Also, an interesting element that we found was the different measurement of utilization. When we started, MSD was measuring the utilization in average kilometers per month, represented by the graphs on the left side. And when we started the layout of the design of the fleet management system, we also implemented the utilization measurement based on days, which then also considers the repair down days, where the vehicles are in the workshop and not available for distribution. And that also increased the utilization rate by a change of a metric. And to have adequate utilization monitoring is crucial for fleet management operation at this scale, because it helps to identify excess capacity and scarce capacities, and this allows to relocate vehicles within the country. Another metric that we're now able to capture is to get reliable and relevant reports on fuel consumption. In this case, we benefited from the advanced fuel card system that MSD already had in place, which allowed to get all fueling information from an online platform and to import that directly into the Excel fleet management system, and thus reducing a lot of manual workload. And for this one, we're very happy to see that this tool now allowed MSD to validate their set fuel efficiency targets, which is the kilometer per liter, and also to identify best-in-class drivers that meet or even exceed the fuel efficiency levels that was set. So that was a very pleasant surprise there. Also, here we can see one of the most important cost efficiency metrics, which is the cost per cubic meter on a vehicle level, and also the different cost components. And while the total cost per cubic meter itself already allows comparison between the different vehicles, so different models, different types, the vehicle ages, or the drives even, it also provides an insight on the different cost elements, such as depreciation, here in blue, fuel, yellow, the insurance, maintenance, repair, overhead costs, and these things. Here we were able to show that while the fuel is one of the most discussed cost components, but when thinking about fleet, in many cases, it's not the most relevant one, as you can see that, for example, the depreciation is has a larger share than the fuel cost on the overall cost. The last metric that we wanted to show, this is again the MDHQ view and the last graph, and it's very similar to the one that we've shown before. So we have the 3 zones that took part in this pilot, so Dar es Salaam zone, Dodoma, and the Dar es Salaam logistics. And this allows the central fleet unit in MDHQ now to take strategic decisions regarding the relocation of vehicles, identify best practices, and directly address areas of concern, having this overview. So we hope we were able to give you a little insight into how MSD and WFP together improve the Tanzanian health supply chain by strengthening the MSD fleet management. And also thanks again to the sponsors, Chimenge, the William Davidson Institute, and USC Marshall. Thank you, and over to my colleague.
Hello, so that would be me, Silvia Rosita Fury here from WFP HQ. Thank you everyone for attending this conference. I'm part of a team that is dedicated to technical assistance for public health supply chains. We are presenting this project today, but also another one still today on supply chain visibility as part of a broader project funded by the Bill and Melinda Gates Foundation, which I thank in this occasion. I will stop here for questions. Thank you.
For any questions, feel free to, just raise your hand and then unmute yourself and ask the question directly.
Thank you, Damini. Thank you very much for the presentation. It's really great to learn how WFP has supported MSD in fleet management. I wanted to understand a little bit from the dashboards that were presented. Since they were Excel-based, how were these dashboards used to coordinate the different MSD zones that are located at different geographical settings in Tanzania? I ask this because it's my understanding from working before with MSD, whenever we have these dashboards, we've always wanted the visibility between the zones and from one zone to another to have that visibility, but I wasn't sure how this was achieved through the Excel-based dashboards. Thank you so much.
So in this case, we used the MSD internal shared, they have a shared folder, shared drive, basically. It's an internal sharing system, which is secured by the IT standards, and that allowed us to share the files on the systems, basically, that we were using in the different zones to a team in the HQ in Dar es Salaam, and they could then extract all the data from the zonal systems and insert it into the HQ system. And by that, all the information could be captured in HQ. And then there was the first step, and the second step then to enable the zones to compare the performance between each other. They would share then the reports from HQ to these zones back, so they could see where their performance is in relation to the other zones. Does this answer your question? Over.
Yes, thank you, Paul. Nicely done.
Great. Did anyone have any other questions? And also, presenters, if you had anything more to add, feel free to do so, given that it was a recorded presentation. So I guess I had a question. I was just wondering a little bit about some of the tracking measures that were mentioned. And I know it seems like in the cost elements, it seems like depreciation was one of those large cost items. I was wondering if there are any initiatives that might be taken to see if that can be reduced in the long run, or kind of just like what some action items might be arising from some of the insights that were uncovered.
Yeah, I would also start to answer that. Riaz, Silvia, please feel free to join in. So one of the outcomes from the results was that the fleet size per zone may be reviewed. So the high cost of depreciation is, of course, because there are a lot of trucks in the different zones, and given that the utilization was not at its maximum, it would be possible to relocate some of these trucks to another zone or to the HQ, and by that the total fleet size in that zone would be reduced, and by that also, of course, the cost for depreciation. While the required capacity in a given zone would remain the same, the other cost would go up, and like the percentage of that cost would go up, but the depreciation could be reduced by that action of relocating the trucks to where they are needed, and if they're not needed, then to withdraw them from that zone. Over.
I think the efficiency was gained basically by taking several measures, and a couple of them were like matching the type of service with the type of trucks. For instance, if you have large size trucks, they to be used on long haul, and the smaller trucks for local distribution. So only by adjusting these things was a good way of achieving some efficiency gains. On the other hand, also training the drivers on how to find the right route for a particular service, because if you go through heavy traffic routes, obviously the fuel consumption on those trucks was higher than other routes that may be longer, but your trucks are not idling for a long time. Another measure was to optimize the load on the trucks. Obviously, if you run the truck with half load, the cost per delivery would be higher. So matching the delivery duration, the delivery frequency, choosing the right route, and choosing the right type of truck, the right type of service was a main factor. The other factor that we introduced to the MSD was also make a combination between using your own fleet and outsourcing to private sector. In all these situations, the private sector has a strong role to play. So this project had two elements: outsource wherever possible, especially on long haul, and use your fleet more tactfully and more strategically. So these were different factors that contributed to the cost efficiencies, and this was visible very quickly to the MSD staff. Thank you.
This is Gerard Robello from WFP. Can I come in, please?
Sure, please.
No, thanks, colleagues, for this exciting presentation. I know I'm part of the team, and I've been involved in it. But I think it will be important to highlight to the guests on this session the element of change, and I think this is important when we are talking about introduction of in this, in any form of technology. There's the people element, the process element, and the tool. So yeah, we focused a bit on the tool here, which is fantastic, but I know the team went through challenges or managed the process side and the change side. So would be good to highlight to the listeners here a little bit about how you went through the process of change with MSD. Over.
Maybe I can come in again at this stage, and thank you, Gerard, for raising this question. I think the first and foremost is the approach. it's important to understand that this was not a top-down approach. The important thing about this partnership was that the MSD, the government of Tanzania, the Ministry of Health, was fully on board since the beginning. They had buy-in, and they were involved at every stage of the project, right from the start, right from the initial discussions to identifying the problem, to finding the solutions, to testing those solutions. They were involved, and I think this is the key in any capacity development project. It's not a PowerPoint type capacity development. It's like holding their hand and walking with them, and walking to a certain distance until they are fully confident. And this was the case, as you saw it in the video. MSD personnel at different levels, they were very open to this process. And I think this is what Gerard alluded to, that how we achieved this target was basically working hand in hand with the government of Tanzania itself.
Perfect.
Thanks, Riaz. And I think you feel comfortable to hand this over to MSD and for them to continue using it pretty much on their own now, correct?
On this one, I would say that I already see the sustainability of this project in a way that the MSD top management has changed. But the new management, when the new director joined, he took over the project, and in fact, we handed over to the new management, and they were open, and they had instructed their colleagues in the unit to fully implement all the recommendation we had jointly developed. Again, these are not WFP recommendations; they were jointly developed together with the MSD staff. So I'm fully satisfied that this project will continue. As I see, even after the project was over, we have MSD staff visiting our office to see a number of other things, other tools that we are using. So it's very encouraging for me, and for me, it's a good model for capacity development in any situation.
Great, thank you so much, Riaz. I'm going to go ahead and present the second track now.
Hello, everyone. My name is Lewis, and today I'm speaking on innovation in the delivery of healthcare. I'm the Director of Flight Operations at Swoop Arrow, and Swoop Arrow is a health logistics company dedicated to developing and implementing safe, reliable, and sustainable networks that underpin responsive community healthcare. And I'll talk about that in a bit more detail later on during this presentation. During this presentation, I'll be delving into the requirements for innovation in the delivery of healthcare, and I'll share my own experience utilising drones as a specific technology to support improvements in the supply chain health outcomes around the world. So kicking it off, why do we need innovation? And specifically, why do we need innovation in the delivery of healthcare? Well, the scale and pace with which COVID-19 has spread across the world has highlighted the fundamental risk posed to the international community if we fail to plan strategically for a disease outbreak. In my opinion, COVID-19 has brought to light the fragility of global supply chains, as well as exemplified the pressures placed on governmental authorities to respond promptly to emergent health needs posed by the exponential spread of the virus. Throughout this pandemic, I think we've all seen firsthand the complexities of rapidly putting in place sanitisation, segregation, and testing systems to limit the virus's spread and its subsequent impact. However, in saying this, the need for healthcare improvements does extend beyond the pandemic alone. The pandemic context has simply magnified the need to address traditional and persisting healthcare needs within those domestic healthcare systems. This includes an extent to the transportation of medical commodities to and from hard-to-reach areas, rapidly, reliably, and whilst maintaining cold chain requirements in what is often an extreme environmental condition context. From this, it's clear that large investments are required to build a robust and resilient health supply chain and consequently preserve and improve the good health and well-being of populations around the world. Overcoming these challenges requires a consolidated, unified and integrated approach, leveraging utilisation of modern technology to not only improve health outcomes, but do so in a scalable and cost-effective manner. So looking specifically at the requirements of such a solution, naturally drives us towards a focus on supply chain logistics, with UAVs or unmanned area vehicles presenting as a modern day solution that overcomes many of the traditional challenges faced in the transportation of medical commodities. These challenges include long distances over difficult to navigate terrain, with complexities such as the lack of road infrastructure, high cost of petrol, limited access to vehicles, all often causing unavoidable delays to medical supply delivery and patient sample pickup. We've also got areas that are prone to significant weather events such as flooding without notice, which cuts them off from the traditional logistics supply channels. And this requires a rethink of how we can continue to maintain access to healthcare in these scenarios. We also often see multiple transportation methods being utilised, such as cars, boats, motorbikes, bicycles, and on foot. And it often means that items are passed from individual to individual in attempts to get them to their final destination. Pair this with poor communications infrastructure, and it makes requests for medical commodities difficult, with regular transport schedules often required to facilitate timely processing of patient samples. In response to all of this, over the last 4 years, we've seen the adoption of UAVs, or more commonly referred to as drones, increase in areas where the benefits tend to be realised the most. Specifically, we've seen exponential growth across Africa to strengthen and expand the existing health supply chains that exist there. Some examples of this include in 2016, development of a partnership between the US startup Zipline and the Rwandan government, utilising a fixed-wing UAV launched via a catapult. It would go out, airdrop supplies, and then return to be captured and returned to the ground via a catch wire. In 2019, there's an activity that I've been specifically involved in, a partnership between our Australian startup Swoop Arrow and the Malawian government was established. This utilised our powered lift aircraft, which combines the benefits of vertical takeoff and landing capability, as well as the range of forward flight, where we established a two-way medical logistics service between difficult to reach locations in the Kata Bay region of northern Malawi, as well as in the Sondashi and Chikwara districts of southern Malawi, and those services continue to date today. Complementing this, in 2016, a study was conducted by the World Health Organization and MetaNet, looking at the efficacy of drones for the carriage of dried blood samples. So drones are clearly a solution to a problem that exists, and supporting government recognition of this and the utility of drones. A number of nations have taken positive steps to progress the technology and support the requisite assessment approval to facilitate its use. In August of 2017, the Malawian government and UNICEF partnered to open Africa's first humanitarian drone corridor, which segregated appropriate airspace in remote areas for the purpose of drone testing and subsequent regulatory assessment. This testing corridor has facilitated drone testing with a focus on activities such as imagery collection, connectivity and transportation, whilst allowing for a safe and controlled environment for the demonstration of these emerging airborne technologies. So looking now specifically at Swoop Arrow, who we are and what we do, we're an Australian drone-powered health logistics company. So our vision is to transform the way the world moves essential supplies by making access to the air seamless. What we're doing is bringing healthcare logistics into the 21st century by deploying a two-way drone network. Our goal, as indicated on the slide there, is to provide a sustainable logistics service to 100 million people by 2025. From the UN to USAID and the Gates Foundation, Swoop Arrow is trusted to create value by sustainably transforming health supply chains to improve health outcomes in every community and every country in which we operate. Our forward-thinking approach to health and successful operations in 3 continents has led us to be recognised globally now as the #2 player in aeromedical logistics. The integration of air logistics alongside traditional transport and operated as a single network provides an opportunity to transform the supply chain and harness the full power of data. In healthcare, this means seamless, urgent, and routine transport of supplies and samples. It keeps the supply chain moving smoothly at all steps of the way, and with reduced human interaction facilitated through a high level of automation, it generates faster delivery times and a safer, more comprehensive solution, particularly in comparison to traditional delivery methods. In terms of where we're operating at the moment, as a company, Swoop Arrow started with its minimum viable product in Vanuatu on the right-hand side there, specifically on the Epi and Eramongo Islands in 2018. And since then, we've expanded to complete a combination of phased proof of concept trials, as well as sustained operations across Africa, including Malawi, Mozambique, as well as the Democratic Republic of Congo. You'll see Australia listed there as well, which is our hometown. And we're deploying a network here over the next month once we receive our regulatory approvals. So looking at what our health supply chain that utilises drones looks like in practice, here we've used Swoop Arrow's operations in Malawi as a specific example. So we're currently operating alongside the Ministry of Health to achieve improved health outcomes across a number of regional communities within Malawi. We work alongside and integrate with existing health supply chain solutions such as Riders for Health to reduce delivery times and facilitate a two-way transportation service of commodities such as vaccinations, medications, pathology samples and results. And you'll see an example of all of those there on the bottom of the slide. We utilise existing health staff who are provided with brief training on how to prepare for the drone's arrival and facilitate its departure. And we also utilise standardised ordering processes to request medical deliveries as well as pickups for patient samples as they need to be processed. At this current point in time, we've got 6 full-time Malawi members who run the service. And one of the predominant challenges we faced with the COVID-19 pandemic was that we'd only completed a basic level of training for the staff that we had there at that time. And we were then put in a situation where we had to repatriate our head office Swoop Arrow staff back to Australia. But what we did find was that through a combination of online training and utilisation of the experience in our local team from Carter Bay, as well as the level of automation in our platform, we're able to continue training up the local workforce remotely, and that facilitated a lot of the metrics you see on the bottom of that slide there, including over 1,900 flights, which has consisted of 36 emergency flights to 38 health facilities. It's also worth noting here that when operating in a highly contagious environment, such as that that's been generated by COVID-19, we found that the automated transportation medium can be easily sanitised on both departure and arrival, whilst assisting in reducing human-to-human contact and the subsequent virus spread that can lead to. So looking at supply chain integration, I did mention earlier that supply chain integration is a key component of facilitating sustainable health outcomes alongside existing solutions. Through an understanding of the challenges, the limitations and scope of service of the existing solutions that are in place, and innovative solutions such as drone logistics can expand and work alongside those solutions to complement their existing utility. This can facilitate a reduction in wasteful spending in cases where the low capacity of an expensive to run transportation medium is underutilised, while still realising the full potential of a service such as an airborne logistics service. This approach allows a reduction in response times, including the ability to respond to emergency deliveries, establishment of on-demand supply chain, as opposed to a schedule-based supply chain, and potential expansion to otherwise unreachable locations, all whilst maintaining the existing workforce and the benefits that that workforce and the existing solution provides. Drawing it back into what we found at Swoop Arrow based on our experience is a direct benefit from working alongside Riders for Health as one united front. And we've received immediate feedback on service implementation as to the recognised benefits of the drone logistics service, with open recognition of some of the restrictions Riders for Health face, and where Swoop Arrow has been able to fill those gaps with our aeromedical logistics network. Alongside this, transitioning to an on-demand supply chain reduces stock, minimises spoilage, enables samples to be taken and processed according to patient requirements rather than in line with a predetermined schedule. Reduced response and transport times has meant patient samples are more likely to achieve an accurate result, with those results able to be rapidly and directly delivered back to the health facility, which directly services the patient and their health outcomes. I'd like to take this opportunity to give a quick shout out to our global partners. They've all been instrumental to the service Swoop Arrow has been able to achieve today, and it's really been incredible to see so many different organisations come together and unite towards the common cause of healthcare supply chain improvement. There is plenty of scope to continue to expand and continue this trajectory in the years to come, and we're excited to do so. If you are interested in supporting our cause, though, please do not hesitate to get in touch either via our website or through our email. So to conclude, we must continue to recognise where there is scope for improvement in our existing health solutions globally and seek to facilitate these improvements through innovative technology. UAVs are just one of these potential technologies, but they have shown an immediate positive impact, and it is a testament to the resources spent during testing and implementing these solutions that it's more than compensated by the improved health outcomes they provide. As we continue to develop strategies as a global community for dealing with the COVID-19 pandemic, it is important we continue to consider the role of innovative technologies and what they can provide in improving the effectiveness of such strategies. From the maintenance of existing healthcare systems to the effective and widespread delivery of the COVID-19 vaccination, innovative solutions present as a natural choice for increasing reach and reducing costs with the global community, ultimately benefiting as a result of those reductions in costs. So that's it from me. Thank you everyone for your time. My name's Lewis, I'm from Swoop Arrow, and I believe we'll open it up to questions there.
So I think no one from the Swoop Arrow team was able to join us for this session. So what we can do is you can either just email me your questions or ask them right now, and I can pass them along to the team and have them respond to you. So we're going to move on to track 8.3 now.
Okay, so thank you very much. I'll be walking you through the presentation from Global Health Supply Chain Zambia, Darwin Chimenge. I'm the data analytics manager. So I'll walk you through two tools, advanced analytic tools. One is the stock redistribution tool, and the other one is the hub capacity tool. So maybe we can move to maybe page 3, so that people are able to see the details that I've just talked about. Yes, so I'm representing PSM Zambia, and I'm presenting on data analytics and application for logistics and supply chain management in Zambia's public health supply chain. So maybe we can start. As you know, COVID has come with its own challenges, and that also has come with public health restrictions in terms of movement. And at the moment, it's not possible to actually provide direct oversight, to facilities that we support. Or another challenge that has been there is actually to effectively and manually analyze high volumes of data, to actually inform supply chain decision. But of course, with the development of these tools, it has enabled us to actually identify risks and opportunities for supporting timely, supply chain decision making, or to actually take timely action in order to effectively, attend to supply chain issues. So some of the challenges that there have been analyzing high volumes of data, and also looking at the restrictions. It's been hard to actually reach facilities because we are not traveling at the moment to provide technical assistance. Before COVID, PSM Zambia actually developed ways to work remotely just to reduce on the physical, travels to these sites, and also how to improve data use, within the supply chain. So the work of these tools has actually just been accelerated and increased, because of the COVID-19 pandemic. And this has enabled the Ministry of Health and also medical stores to sustain, and strengthen their supply chain. Next. Okay, so the two advanced tools that I'll talk about, one, the stock redistribution tool. This is basically a GIS-based tool that actually uses GIS data. All these facilities are mapped to actually look for opportunities in terms of stock redistribution. To look at facilities that have less stock and link them up to facilities that have actually more stock, those overstock facilities, so that redistribution opportunities can be done within the province or the district. Another tool is the hub capacity tool. This is an Excel-based tool which is used for strategic, hub decisions to actually determine the amount of stock that can be stored in our regional distribution centers. Unlike all the stock being stored at the central warehouse, the regional distribution centers, which are hubs, are much closer to the facilities. And by doing that, to ensure that facilities will have, accessibility to products in the nearest proximity. Next, please. Okay, so I'll talk about the stock redistribution tool first. With over 2,800 facilities, and of course hundreds of commodities to analyze, stock redistribution tool used to take a lot of time and also quite intensive and prone to errors. And also the high chances that you'd overlook redistribution opportunities because things will be done manually. But in 2019, PSM implemented the stock redistribution to more of automate the redistribution opportunities of different products. The stock redistribution tool leverages on data from the existing LMIS, and it actually automatically analyzes this data to identify or to look for stock transfer opportunities to support supply chain decision making at the provincial health level. And this tool is actually inbuilt with intuitive interfaces where the user is actually able to look at different stock statuses of the entire province, or they can actually focus on a specific facility. So the tool will have pointers, on the visual where, it will show you facilities that are overstocked and also understocked. And then it will suggest the nearest facilities in kilometers that are overstocked, where those stocked out or understocked facilities can actually draw stock from. Next slide, please. Previous? Yeah, sure. Okay, so this is what I just talked about. So this is a map-based interface for making stock redistribution opportunities. And this also, supports remote decision-making, from any location. So those pointers you're seeing on the map, it's only not very visible, but those pointers are actually facilities. Then the dots are facilities. The lines you're seeing, those are showing the distances between the facilities. And the color codes there, you see the ones in red, all those are overstocked. I think there's orange, which is understocked, and should be blue adequately stocked, and green, which is stocked according to plan. So what happens is, if you click on a facility that is overstocked, it will suggest the closest facility which is overstocked, so that that can be an opportunity to redistribute, some of these commodities that may overstocked. That will also enable, prompt supply chain decision, and to ensure that, products do not expire from those overstocked facilities. And also it will ensure that facilities are replenished with stock from nearby facilities before the central level medical stores can actually replenish them. Next slide, please. Okay, so like I earlier mentioned, I touched briefly to say this is a GIS-based tool. All those facilities are actually mapped with coordinates, which determines the distances between the facilities. And the tool, of course, leverages or uses LMI stock imbalance data. So this is the stock data that is actually pulled from the LMI system. I think I earlier touched on identifying stockouts, understocked, and overstocked facilities at commodity level. The quantities will actually be displayed, for each facility that is overstocked, so that it can be determined like how much stock can be drawn from that facility to a facility that is stocked out or understocked. So redistribution will actually be recommended or suggested, to replenish these facilities before they are actually stocked out. Next slide. So if we look at the results of the stock redistribution tool, it has actually come in handy, in this time of COVID. Despite the physical presence, we are unable to actually visit these facilities and make those, supply chain decision in terms of redistributions. But right now with the COVID, this tool has supported remote decision making, for stock reallocation opportunities in different provinces where overstocked and stocked out and also expiries are actually prevented. Between May and August, GHSPSM and the implementing partners in Zambia here have actually resolved multiple, supply chain risks, which included the redistribution of Dipro-Provera, in one of the districts in Osaka, which is Chilanga, and also other drugs ranging from, essential medicines and ARVs, and also viral load reagents in other provinces, like the Western province. Malaria medicines, mostly ACTs, have also been redistributed, within Wangwa district. Next slide, please. So the next tool is the hub capacity tool. This is a medium-term planning tool, which can support, operational rollouts, for provincial hub, which are our regional distribution centers. So the previous one, the stock redistribution tool, is more on the operational level, but the hub capacity tool is more of a strategic tool. At the moment, this is an Excel-based tool, which was launched way back in June as a tool to actually assist the central medical stores to derive or to arrive at decisions about which commodities can actually be kept in each regional distribution center. The main objective was actually to reduce on the number of commodities that would be managed at central level, so that key commodities, can be pushed down or can be made accessible closer to facilities, because we have regional distribution centers being more closer to facilities than the central level. And then MSL will use this to, again, to determine the commodities which should be stored at each regional hub. And also that includes the volumes that will be stored, because of course regional distribution hubs will have different capacities, that they have to actually store these products. Next. Okay, so how does the hub capacity tool actually works? So the tool will help determine what stock can be kept at regional distribution centers, which are provincial hubs. Of course, this would factor in different parameters that the user has to input. For example, the size of the hub, in terms of volume, the inventory rules, policies that apply to keeping stock, and also the position of the pallets. Also, another thing that will be considered are the facilities that are actually serviced by these different hubs. And also the priority of commodities that are to be stored. For example, in the areas where, malaria is rampant, of course, you'd ensure that, you have enough ACTs stored in these hubs as a priority. The tool also looks at, historical data in terms of orders for each facility, and also cubic volume data, which is actually used to determine the commodities that can be stored in each hub. The user is actually at liberty to, work around these parameters. Typically the inventory rules should also be used to make the final decision about, inventory, which commodities, the inventories and which commodities can be stored. So in the end, the stakeholders, which are medical stores, and the Ministry of Health, can actually derive insights, on hub volume capacity, which they can actually use to for decision making on inventory rules. This can also apply to decisions related to transportation, and also ordering processes, and to ensure that the supply chain is actually functioning within its capacity constraints. Next slide, please. Okay, so this is just a brief visual of the hub capacity tool. So just quickly there on top, you have the main menu, which will actually let you input the file. The file at that time should contain the districts, and then the number of pallets, and the number, rather the name of the hub where these products will be stored, with any additional notes. And the user can also select which provinces and districts to import the tool. So this tool can be used in individual, warehouses or regional distribution centers, and only those districts within which the regional distribution center actually services, you're able to select only those districts. And also it will allow you to, to allow the user to also name the hub, and also add notes that can go with the analysis, so what the analysis produces. Okay, so this data is actually from the LMIS data, where data can be pulled using the LMIS input tab. Next. So this is just a continuation of the user interfaces, or rather the user interface that this tool uses. Not so much on this one. This one will just show you now, after you import that LMIS template with data, what kind of output you have, that will enable you to actually make decisions for supply chain and also inventory management. Next. Okay, so now on the results of the hub capacity 2, exactly in how the central warehouse, which is the medical stores, how they've used these two in Zambia. Recently, MSL actually completed an analysis of the most commonly distributed products. And after that was done, it was found that, it was discovered that 40 stock keeping units, that were distributed were actually representing 80% of the orders. By also using inventory targets of between 1 and 2 months of stock, and the monthly redistribution data, from LMIS, and also considering other factors like the physical storage spaces at the hubs, it was identified that only 14 stock keeping units can actually be, fully managed by the provincial hubs. So out of the 40, that were redistributed, after using the hub capacity 2 and entering the different parameters, that the user would enter, like the volume of the hub and also the, inventory rules that apply, only 14 stock control keeping units were, identified to be managed by these regional distribution hubs. Now, based on these findings, in June 2020, GHSC, PSM, and medical stores, and also the Ministry of Health agreed to store about 15 of the potential commodities at a hub on the Copperbelt province, which is the Luanshya hub, which allowed MSL to actually redefine their redistribution, or rather distribution strategy, for this province. So instead of having to push down all the 40 commodities, at one regional distribution center, using the two, it was determined that only 15 of these could actually be stored. From this strategy, and also the data that is extracted from the two, our partner, which is MSL, has been able to identify how they also want to use their ERP system. Instead of all the orders being directed to the hubs, others can actually, instead of all the orders being at the central warehouse, actually others can be straight redirected to the hubs, where distribution can be done closer to the facilities. Next slide. Okay, so in conclusion, so these tools have actually been handy, and the fact that, the first one, which is the stock redistribution tool, we started working on this tool even before COVID. And obviously, the main reason for coming up with this tool was to reduce the manual processes and also, time-consuming, activities that, before that were carried out before making supply chain decisions. These tools have also allowed, for speedy action to prevent any risks in the supply chain, like the stock redistribution tool. It has allowed, facilities to be replenished by nearby facilities without the central medical store actually, having to supply them these commodities. And also having, the COVID-19 impeding, technical support, these tools have come in handy because they can be used remotely. And it also shows that, technical support can be provided long-term, even without physically being in these facilities. These tools have also inbuilt flexibility. They can actually be adapted to other countries that are leveraging on LMIS to, to implement, their supply chain, and also any open source tool can actually leverage on these, tools to actually integrate with the tools and also other, platforms. I think that's it. Let's check on the next page if there's anything. Yeah, I think that's it from me. We welcome any questions. Thanks for listening.
Great, thank you so much, Darwin. If there are any questions, feel free to unmute yourself and ask.
Hi, Timani. It's Simon Cole. I'm work with Darwin in Zambia, and just wanted to add something here with regards to the hub tool. What we found with this as well is that because we'd essentially got a fait accompli, we have 7 hubs in 10 provinces. It's a little bit difficult to use this strategically in the full sense of the word. One of the strengths of this tool is that you can take a greenfield site and you can actually work out how big a warehouse you need. Previously, it would just be based on amount of money that a funder would have, or the amount of space or land that you have. This tool allows you to actually say how big this warehouse should be to support 1, 2, 3 months of supply of either strategic products or all of your products. And one of the things that Darwin didn't mention was that MSL have to manage 4,000 SKUs. So it's important that that you are strategic on that. I just wanted to point that out to the listeners here who might be thinking, how can I use this in my country? It certainly would be better to use this up front as you're trying to design your system.
Thank you for sharing that, Simon. That was really helpful.
Thank you, Simon.
Are there any other questions? Otherwise, I have one on the chat that I'm happy to share as well. Great. So a question we had was, for the redistribution tool, how much information in terms of infrastructure was available on the tool? Because the closest facility may not be the easiest to reach always.
Well, let me answer it in the way I've understood. In terms of infrastructure, so I'm not sure if the question is based on the infrastructure that was built that was used to build the tool. So the stock redistribution tool is actually an open source tool. It uses Leaflet, which is a JavaScript library. So in terms of the infrastructure, all you need is any desktop or laptop computer and a browser, to access the tool. And then it just leverages on LMIS data, which is pulled from the electronic logistics information management system. I hope I've answered this question correctly. Maybe the infrastructure part should have been more clear.
I think that was good. Thank you. Great. Well, thank you so much, everyone, for attending. Please join us for the track talks and for a live discussion on these in the AirMeet platform. My colleague Susan posted the link to that in the chat as well, so we can continue these discussions on AirMeet as well. But yes, thank you so much for joining, and I hope the rest of day 2 and day 3 go well.